Hello students, so today there's a 12th video I'm going to send you, and in this video I'll explain you question number 4 from exercise 1C. As you know, from exercise 1C we have already finished question number 1, 2 and 3. These questions we have finished. Okay, so today we'll do question number 4. This question number 4. So as you can see, the question states here: find HCF and LCM of following pairs of integers by applying the fundamental theorem of arithmetic. That means these pair of integers are given to you. These are positive integers. So you have to find the HCF and LCM of these pairs of integers. Okay, HCF and LCM. But you have to apply here the fundamental theorem of arithmetic. Okay, so I've already explained you about fundamental theorem of arithmetic. Okay, I've already explained you about the fundamental theorem of arithmetic. So let us see once again what is this theorem. You can see in your book, page number 8. So see theorem 1, that is fundamental theorem of arithmetic. It says that every composite number can be expressed or factorized as a product of primes or prime number, and this factorization is unique apart from the order in which the prime factors occur. So I've already explained you so many times in the previous video that fundamental theorem of arithmetic is a very important theorem, and it says that any composite number, remember, a number which has more than two factors, any composite number can be expressed as the product of prime factors or prime numbers in a unique way. Okay, the order may be different, but any composite number can be decomposed or can be factorized as a product of prime numbers. Okay, as you know, prime numbers are those numbers which have only two factors. So means composite number which has more than two factors can be expressed as a product of prime numbers. Okay, now that means you have to apply this fundamental theorem of arithmetic to do question number 4. Now let us see some steps or the procedure how we can apply this theorem to find the HCF and LCM of two or more integers. Okay, so for this you have to go to page 9, this page number 9 of your book. So here is the complete theory or explanation regarding application of fundamental theorem of arithmetic to find the HCF and LCM of positive integers. Okay, so let's see how we can apply fundamental theorem of arithmetic to find the HCF and LCM of two positive integers. Okay, before I explain you, first I hope you know the meaning of full form of HCF. HCF stands for highest common factor, whereas LCM stands for lowest common multiple. Okay, so means we're going to apply here fundamental theorem of arithmetic to find the HCF and LCM of positive integers. So let me tell you that integers can be negative also, can be positive also, and zero also, but we are going to find HCF and LCM of only positive integers. Okay, integers having positive sign. So let's start. See, let me just explain you quickly. See, for finding HCF and LCM of two or more positive integers, so you can find HCF and LCM of more than two positive integers also. So to find HCF and LCM of more than positive integers, more than two or more positive integers, we adopt the following algorithm. Okay, so this is the algorithm. Okay, the working procedure. Okay, clear? So the algorithm here says that, so to find the HCF and LCM of positive integers, so this is the proper algorithm. You know, algorithm means what? A systematic way of solving a problem. A systematic way, the step-by-step method of solving a problem. So to find the HCF and LCM of two positive integers, so for the first step here is what? Factorize each of the given positive integers. That means what? Whatever positive integers are given to you, like in question number 4, like 336, 54, we have to find the prime factorization. Okay, prime factorization of these two numbers. Okay, clear? So look, so factorize each of the given positive integers. So you have to do the prime factorization of these positive integers. Okay, then after that express them as the product of powers of prime. That's what we have done in question number 1, 2 and 3. We have done prime factorization, we have found the prime factors, and we express the result as the powers of prime. Okay, means we'll not write 2 2 2 suppose 3 times, we'll just write 2 raised to power 3 or 5 square, like that. Okay, so those prime numbers you raise to power of primes. But the thing to note is what? You should write these prime factors in ascending order of magnitude. For every number, you write in ascending order. Means what? The first prime number which is smallest should come first, and then bigger and bigger, and the largest prime number should come the last. Okay, so express them as the product of prime in ascending order of magnitude. Okay, then see the third step. In third step, you'll find A and B. A is for finding HCF and B is for finding LCM. Let's see how to find HCF. For finding HCF, remember number one, mark common prime factor. Means what? After you do the prime factoration of say 336 and 54, you do prime factoration, you write the prime factors in ascending order of power, means ascending order of prime number with their power. Now what it is that from these two prime factors you mark only the common prime factor. Means what? The prime factors which are present in both these numbers, or if I give you 3-4 numbers, it means you should be present in all. Okay, means common. You mark only the common prime factors and find the least exponent of these factors. So suppose 2 prime factors present here and 2 is also present here, then you see which one has the lower exponent, means power. Suppose here coming 2 cube and here coming 2 square, so 2 square smaller, take 2 square. Okay, means mark the common prime factor with the lowest power. Okay, least power. Then raise this common prime factor to the lowest power. So in this way, whatever common factors are there, only common, I repeat, only common, means which are present in both or all the given numbers, only those common prime factors write with the lowest power and then multiply them. See, and finally multiply them so as to get HCF. That means what? The only common prime factors that you have with the lowest power of these two, you multiply those together, and what you get is the HCF. Okay, clear? Now let's see how to find LCM. See, for finding LCM, it's the same rule. For finding LCM, you have to do the same process only. Factorize and then write the product of prime. Then for LCM, list all prime factors. So I repeat once again. For HCF, you have to write only common prime factor. Only common prime factor. Only common. But here all. Whatever prime numbers are there. Means in 336 and 54, whatever prime factors come in this first number and this second number, write all the prime factor, need not be common. Like suppose we have a prime factor here, say 7, but here don't have, but you can write 7 because it's a prime factor. Okay, so need not be common, means common also take and not common also take. Okay, so write all the prime factors but only once. Okay, suppose 2 is coming here also and here also, just that 2 write once only. Okay, so write all prime factors which occur in prime factoration of the given possible number, which comes in the prime factoration of these numbers. Then raise each prime factor to the greatest exponent. So there's the only difference. For HCF, we take the smallest power. There also we take only common for HCF. But for LCM, we take all the prime factor with the highest power, with the greatest power or greatest exponent. Okay, so that means whatever prime factor here and here, you write all of these, and see which one has the greatest power. Suppose here coming 2 cube and here 2 square, so cube is bigger than square, so we take power 3, highest power. In this way, write all the prime factor with the highest power and multiply them so as to get LCM. So the product of all the prime factors with the highest power will give you LCM, and the product of all the common prime factors with the lowest power will gives you HCF. That means HCF is the product of all the common prime factors with the lowest power, and LCM is the product of all the prime factors with the highest power. Okay, clear? So after having explained you about HCF and LCM, let us see this last part, remarks relationship between HCF and LCM. That means what? Here they have given you the relationship between HCF and LCM of any two given positive integers. Okay, so see, let us read this and then look. For any two positive integers a and b, like this 336 and 54 in question number 4. Okay, in question number 4.1, the two given positive integers are 336 and 54. So these are like a and b. Okay, so look, for any two percentages A and B, for any two given percentages A and B, remember the relationship, the product of their HCF and LCM, that is what HCF of A and B and LCM of A and B, the product, that means the HCF and LCM of this number. Now if you find the product, then that product will be always equal to the product of these numbers, of these integers. Means what integers I've given to you, positive integers, you find their HCF and LCM. That means we have now four things here, or four quantities. There's the HCF of those two given numbers, there's the LCM of those two given numbers, and these are those two numbers, the four things, or four quantities. Now in one side you multiply HCF and LCM of those two numbers, and the other side you multiply those two numbers themselves. Okay, clear? So find that these two product will be always equal. This product will be always equal. It means that the product of two given integers is always equal to the product of their HCF and LCM. Okay, so after having explained these things, so we can see the solution of this question number 4 in the next video, that is video number 13. So this is video number 12. Okay, so here I explain you some theory about how to apply fundamental theorem of arithmetic to find the HCF and LCM. I have given you some rules, so important points. So you have to keep in mind these points, remember these points, understand these points, and with the help of this facts or this algorithm, we can easily do question number 4 from exercise 1C. Okay, so thank you.